Continuing with lesson 1.1, this is the third video, we'll call it 1.1c. And we're starting with the section entitled Standard Position. When you have the XY axis, you have a standard position if its vertex is at the origin and the initial side is along the positive x-axis. So there is standard position. Then any angle that you draw for the terminal side will be in standard position. So it doesn't matter where you put it, that angle is going to be in standard position. All right, so doing Algebra 1, you've learned that quadrant 1 is there, quadrant 2 is there, 3 is there, and 4 is there. You will use this extensively. You have to know which quadrant is which, and you have to be able to use this XY axis because we are going to be using it forever. Okay, so we have another name of some angles. They're called quadrantal angles, and I'll show you where they are in green. The first quadrantal angle will be this one, a 90-degree angle. The next quadrantal angle will be this one, a straight angle, or 180. The next one obviously is going to be this one, and it's going to go all the way around to 270. And the last one then will be 360. In fact, it's really not the last one because this can keep going. 360 plus 90 and then plus 180. I mean, you can keep going around and around and around an infinite number of times. But all quadrantal angles differ by 90 degrees. You add 90 degrees to them and you've got a quadrantal angle. Okay, got a cool XY axis there, so this should make it a little bit neater for you to follow. All right, so if we have a rotation of a ray and it results in an angle measuring a complete rotation gives us 360 degrees. We've already talked about that. By continuing the rotation, angles of measure larger than 360 can be produced. So if I start here and I go all the way around here, that is 450 degrees because it's 360 plus 90. This angle right here is a 90 degrees, but it's also a 450 degree angle, depending on how many times I go around. So when they end, or they have the same terminal side, which in this case is right here, these are called co-terminal angles. They end at the same place. Their terminating point is at the same place. I mean, if I had an angle, I mean, I can go absolutely crazy, which you know me and my math craziness. I start at here and I go all the way around and around and around, and I get all the way over to 830 degrees. Well, that's also a 110 degree angle. So 830 and 110 are coterminal because they have the same terminating angle there. So when you get to example 4 and it gives you a question, come on, go away. Gives you a question such as find the angles of smallest possible measure coterminal with each angle. So what we're going to do in order to find out the smallest angle that is going to have, so let's say you did 908 degrees and you went around and around and around and around and you ended up with an angle right here. They want to know if you didn't go around and around and around, if you just went this far, what would that angle be? So that's why it says find the angles of the smallest possible measure. All right, so how do I do that? Well, it's pretty simple. All I have to do, let's get black here. All I actually have to do is take the 908 and subtract 360. That's 8, 4, 5. And then I'm going to take 360 away from that. And then I'm going to say, can I take 360 from that? No. So this is going to be the smallest coterminal angle with 908. You just keep subtracting 900 or 360 from it until you get a number smaller than 360, and that is the smallest angle that is coterminal or the same angle as the 908. Okay, part B says, what about a negative, whoa, what is that? Negative 75 degree angle. Well, we're going to start there. We're going to go 75 degrees down and end up there. They want to know the smallest positive angle that's coterminal with that. Well, positive means we go counterclockwise until we meet that line there. Well, what angle is this? Well, we know a complete circle all the way around is 360 degrees. So if we take this 75 away from it, we end up with 285 degrees. So that ends up being the angle. Let's do this in pukey yellow. We end up with an angle right there of 285 degrees. So that is the smallest positive angle that's coterminal with this one there. Okay, so that's example 4. So let's finish 1.1 with example 5. It says a CAV, or a constant angular velocity CD player. That means the speed that the CD is going around is going to be constant. It's not going to change. In this particular one goes 480 revolutions per minute. So it goes around 480 times every minute. So it goes really fast. If you've seen CDs go around, they do go around pretty quick. Through how many degrees will a point on the edge of a CD move in 2 seconds? So we've got a CD here, and we've got a point there, and this thing is moving 480 RPMs, revolutions per minute. How many degrees will this little dust speck go in, let's see, 2 seconds? Well, we know it's going to go around 480 times in 1 minute, but we want to find out how many times it's going to go around in 2 seconds. So it is going to go, well, to me, probably the easiest way is figure out how many times it's going to go around in a second. If it goes around 480 times in a minute, if we divide by 60 seconds in a minute, we're going to get how many times it goes around every second. So that CD is, when you go 1001, it's going to have gone around 8 times in that 1 second. Well, what are they interested in? They're interested in 2 seconds. So it's going to go around how many times in 2 seconds? 16 times. Is that the answer we're looking for? Absolutely not. They didn't ask us how many times it'll go around. They asked us how many degrees 16 times equals. So what you're going to do, 1 revolution is how many degrees? 360, because there's 360 degrees in a complete revolution, or in a circle. So if it goes around 16 times in that 2 seconds, you just take 16 times 360, and you get 5,760 degrees that this goes through in 2 seconds time. All right, so that is it for lesson 1.1.